Although a lot of scientists say they're not interested in metaphysics or philosophy and it's a waste of time, they're actually deeply embedded in a metaphysical system. What in think tanks is called the innovation deficit in science it worries a lot of policymakers because more money is spent on science than ever before.
The science really have all the answers. It seems that way at times, especially if you listen to public-facing scientists. People use the science as an appeal to authority to make a host of different arguments on topics ranging from ethics to geopolitics to the hot news item of the day. There's also a broader sense in which science claims to explain things that haven't yet been proven. For example, views like the universe is inherently material, whatever that means, and that there's no broader sense of purpose to it at all, or that free will and agency are just an illusion, that all of our behavior is just determined by prior physical operations we just don't know yet. The open-ended sense of mystery that once animated scientists seems replaced by a view that all the interesting questions have already been answered, and all that's left for us is really just to fill in the blanks with the details. In parallel to this, the scientific establishment, even as it continues to innovate in all kinds of amazing ways, has grown narrower in some respects. Studies in Nature and elsewhere show that scientific papers and even patents are getting a little bit safer than they used to be, and they're less and less likely to break with the past. NIH grants are going to older and older researchers. Younger researchers with novel ideas are having a harder time getting funded. There's evidence that science is becoming safer in a lot of ways and less adventurous than it used to be. Is it possible that something was lost along the way, that our curiosity and openness to radically new ideas has gone down as science has become a little bit more conventional and bureaucratic? That's the question my guest in this episode of the podcast, biologist and author Dr. Rupert Sheldrake, has been exploring his entire career. He's made waves and ruffled the feathers and egos of his more mainstream colleagues for years, for really poking holes in their sense of absolute certainty about the big questions, and for broadening our view about the questions that science can legitimately explore. His book, The Science Delusion, which I highly recommend, and his ensuing TED Talk, which was famously banned. If you Google it, you'll see it's the banned TED Talk, explored all kinds of interesting and weird avenues, like whether nature is actually conscious and whether the laws of nature don't actually function like habits rather than ironclad laws, seeing as even constants can change depending on when you measure them. His later work focuses on spiritual practices and all the different forms of spiritual practices that humanity has developed, and the growing body of evidence linking them to all kinds of benefits. Hardly something a serious scientist is supposed to study. I've been following his work for years, and I've always wanted to interview him. So it was a ton of fun picking his brain in this interview. Get ready for a renegade history of science and linking scientific thoughts and concepts to all kinds of strange and interesting ideas. It's the kind of fun and adventurous hypothesizing I wish we saw from scientists more often. I hope you enjoy this one. This is my conversation with Rupert Sheldrake. Dr. Rupert Sheldrake, I've been following your work for years. It's a real pleasure and honor to have you here with me.
Very good to be with you, Fred.
So with your permission, I'd like to start in the beginning. And I mean the literal beginning, namely the beginning of the universe. For a long time, scientists believed that the universe had just been around forever. When evidence of the Big Bang started accumulating in the early to mid 20th century, it took scientists a long time to accept it because the whole notion of the universe having a beginning seemed too close to the premise of religions. Today, I believe most scientists accept the evidence of a Big Bang and an expanding universe. So the universe essentially going from a state of non-existence to a state of existence. There's a quote that you've referred to many times. I believe you got it from the great Terence McKenna. And the quote is this: "Modern science is based on the principle, give us one free miracle and we'll explain the rest. And the one free miracle is the appearance of all the mass and energy in the universe and all the laws that govern it in a single instant from nothing." My first question to you is, Why is this nothing or random origin principle seen as the most rational one by scientists? And if the universe doesn't come from nothing, what's your best current hypothesis of where it does come from?
I think the main reason that most scientists want to, well, not most, but some scientists want it to come from nothing is because they don't want to have God involved. One of their primary motives, they think they'll get rid of God. But of course, traditional Christian theology, as in St. Thomas Aquinas and others, also has God creating the universe ex nihilo, out of nothing. So it's not that actually far away from Christian theology. The difference is, in Christian theology, according to Aquinas, if God creates the universe out of nothing, then everything in the universe has come forth from God and is therefore has a divine origin. If it comes from nothing without God, if you look at, there's a chap called Krauss, he's called Leonard or Leopold or something Krauss, who's one of Richard Dawkins' atheist friends, who wrote a book called A Universe from Nothing, which he considered to be a refutation of God. And so when you actually read the book, which I have done, what was nothing from which the universe came? Well, the answer is the laws of nature. He takes those for granted and presupposes them. And then all the energy in the universe, he says, arose from a random quantum fluctuation in the quantum vacuum field. Well, according to modern quantum physics, the quantum vacuum field is not empty, it's full of energy. So he actually starts with laws and energy. He doesn't start with nothing, but he gives no explanation whatever for the laws and energy. Whereas in a traditional theistic account of creation, then you'd have God as the source of the laws and of the matter and the energy. Well, Krauss would just say, you don't need God, you can just have nothing instead. But then, of course, he has the problem that all materialists have of explaining consciousness, because his aim is to get rid of consciousness from the whole universe. It's just impersonal laws and mindless matter and energy. So then he falls into the same problem as other materialists. How come we're conscious? We ought not to be. Whereas the advantage of the God hypothesis is that consciousness comes first, and therefore it's not surprising that consciousness turns up in the universe, at the very minimum in our own brains, and probably very much more widespread.
And it's funny because it's almost like in this train of thought, we go from nothingness or randomness straight to these ironclad laws of nature, skipping the hypothesis of, let's say, something like an intention or something like design. These laws of nature would have had to be, and I'm just pushing a little bit on the notion that randomness is the most rational hypothesis when it comes to metaphysics, because science does accept the fact that we do have these very precise laws, and they are what they are, and they are not something else. Don't you find that there is a little bit too quick of a jumping from nothingness to absolute perfect laws?
Yes, and the reason for it is historical. In the 17th century, when modern science got going, the founders of modern science were all Christians, Newton, Descartes, Leibniz, and Galileo, and so on. And they thought that the laws of nature were ideas in the mind of God. They thought of God as a kind of engineering God who designed the universe as a machine, imposed the laws of nature, fine-tuned them so they were just right for this planet, then, as it were, pressed the start button, and then nature went on more or less automatically. That was their view. So they had a kind of view of God as an engineer and a mathematician external to the universe. The laws of nature were immortal, immutable, omnipresent, omnipotent, etc., because they were part of God's nature. They partook in the nature of God. So when in the 19th century materialism and atheism became so predominant within the sciences, they just simply rubbed out God, and they left free-floating laws of nature, which are a kind of relic of 17th century theology. And this became a sort of built-in habitual assumption to science, and is actually rather an embarrassing one for proponents of the Big Bang, because when they assume the laws of nature are all fixed and have never changed, the question arises, why are they exactly right for life to appear on Earth? So one group of theoreticians say, well, there must be a kind of old-style deistic engineering God who fine-tuned the laws of nature so they were exactly right for life on Earth. And the other lot say, well, there's no such thing as God, so how we explain it is to say there are trillions, quadrillions of actual universes, and we can only know the one that's just right for us, and all the others actually exist. And when I asked one of the proponents of this view, Lord Rees, who was president of the Royal Society here in Britain and Astronomer Royal and Master of Trinity College, Cambridge, how he could adopt a theory that had not a shred of evidence and seemed like the ultimate violation of Occam's razor, the principle that you should have the minimum number of explanatory principles. I said this sounds like the ultimate violation, having an almost infinite number of actual universes. He admitted there was a problem with Occam's razor. He said, yes, I agree there's a problem with Occam's razor. We're working on it. And I said, well, why would you want to have such an extravagant view? And he said, because this way we can get rid of God. But the thing is, they don't get rid of God because, as theologians point out, an infinite God could be the God of an infinite number of universes. So instead, they've simply proliferated universes. But this whole debate, whether there's a universe with a fine-tuning external mind, or whether there's an indefinite number of actual universes, evaporates like the morning dew in the sunlight if you drop the idea of eternal laws of nature. And that's, of course, what I do in my idea of morphic resonance, seeing the regularities of nature as more like evolving habits.
Yeah, and we'll get to that. I'm very interested in morphic resonance. Before that, I want to ask you a question really as a scientist, because I know that you do science, you think like a scientist, but you also have a more open-mindedness when it comes to, let's call it metaphysics or ideas of theology and so forth. But strictly from a scientific perspective, it seems to me that starting in the maybe 18th, 19th century with the paradigm of materialism, science took the certainty that we can derive in the clear sort of physical and chemical laws of nature and started applying those to metaphysics. And personally, I find there's no problem with a sort of agnosticism. Agnosticism, I find, is very compatible with the scientific method and with scientific ideas. But we seem to be dealing with more than that from material scientists. They have a tremendous amount of certainty about matters of metaphysics. They know it's this and it's not that. Is it possible for somebody who's really just a good faith scientist to really derive the same sort of certainty that they do with material laws with metaphysics? In other words, the origins of the cosmos. I know, for example, that Stephen Hawking took position that it would be very hard to do that because science is based on measurement, and science is based, and we can't measure what existed by definition before the laws of nature and before matter existed and before energy existed. Is there a sort of a deeper philosophical problem for a scientist to make very certain claims about matters of metaphysics the way that a lot of mechanistic materialist scientists seem to be doing these days?
Yes, I think basically what they have is a dogmatic metaphysical system, but they don't realize that it's a metaphysical system. They think it's just the truth or the facts or something like that. Basically, the mechanistic view of nature, that nature is made of mindless matter governed by mathematical laws, developing in a purposeless way. That's the basic assumption of materialism, with no consciousness doing anything in the universe, is simply an assumption. It's a metaphysical assumption. And its historical origin, I think, it's helpful to see its historical origin because at the beginning of the 19th century, most scientists believed in Cartesian dualism, the idea that Descartes put forward in the 17th century that said there's two kinds of reality. There's material reality, which is extended in space, res extensa, extended things, which is unconscious and is matter, and the whole of nature is nothing but res extensa, mindless, purposeless material. And then there's the realm of consciousness or spirit, which consists of God, angels, and human minds. And so it was the dualistic split. And in practice, it worked quite well for a while because it meant that scientists got the whole of nature as their domain, and they could function fairly independently of religion, whereas religion got God, angels, and human minds, including morality, as its domain, and could go on in that area without messing with science. Or basically what it did was desacralize the whole of nature and handed it over to science and kept religion into a restricted compartment. So in the 19th century, many philosophers thought that this dualism was not a very good idea, and basically instead of having two quite different things, you should just have one thing. They thought two was too many. So the materialists said, well, get rid of God, angels, and mysterious human minds that are not material. And then you've just got a materialist universe with no God, no angels, and no mind that's separate from the brain. Whereas the other school of thought, the idealists, said, well, get rid of the idea matter's the fundamental reality, say consciousness is the fundamental reality. And then matter's kind of dumbed down mind. So then from thereafter, the materialists had the problem of explaining mind, and the idealists had the problem of explaining matter. But that's because they were reducing a dualism to a monism from two principles to one, because they thought two was too many. Personally, I think two is too few, and I think actually we need three fundamental principles, which we can come to later if you like. But so I think that this dogmatic materialism arose simply by cancelling out the whole realm of consciousness in order to, they thought, simplify things and get to a monistic materialism. And it's a purely metaphysical system. And so, although a lot of scientists say they're not interested in metaphysics or philosophy and it's a waste of time, they're actually deeply embedded in a metaphysical system without being aware of it, which is not a very good state to be in. You can't criticize assumptions if you don't know you've got them.
Yeah, and we'll get back to the assumption of materialism, but just because it's really central to this point, going from dualism to monism, what are the three perspectives or the three pillars that you see as a more proper metaphysics?
The three principles that I think are involved is a kind of Trinitarian principle. We find in many different systems, Hindu, Christian, that you can find it in many different religious traditions, that ultimate reality is threefold or has three aspects. The Hindus call it Sat, Chit, Ananda. Sat is being, the conscious being. Chit is the contents of consciousness, names and forms. And Ananda is bliss or joy. In the Christian version, God the Father is conscious being. God's first statement about himself to Moses is, I am who I am, or I am that I am, conscious being in the present. And then the second person is the Logos, which is like names and forms in Hinduism. It's the structures, forms, names and things. Consciousness by itself doesn't have content, but all our minds have content. We have names, forms, images, structures. The Tibetan Buddhists compare it to a mirror. The consciousness is that which can reflect all names and forms, but is not itself those names and forms. You can distinguish between the ground of consciousness and the contents of consciousness. And then the Holy Spirit in the Christian Trinity is energy, is the principle of flow, movement, and change, always represented by fire, wind, breath, the flight of birds, and so on. It's the dynamical principle. And if you take that view of the Trinity, then of a Trinitarian basis of things, then we see reflected in nature, within the scientific view, energy, which is one of the fundamental principles of science, fundamental energy flowing through all things, the principle of actuality, movement, and change. And form, which is mainly expressed through fields. So matter in modern physics is energy bound within fields, like an electron's a vibration in an electron field in quantum field theory. So fields and energy are the fundamental principles of nature, and they're grounded in a common source. So we actually do have a kind of reflection of a Trinitarian principle in the whole of nature.
Very interesting. And just because speaking Hebrew, that original statement of God to Moses is, I know it's commonly translated as "I am that I am," but it actually, the textual, the literal translation is "I will be what I will be." And it's almost that principle of pure attention. It's like, pay attention and you will eventually know in the unfolding, you will know what I will be. So it fits what you're saying in terms of the pure consciousness. And so if I understand what material scientists call matter, you would see in the third pillar of energy and motion, right? Is that where you see what we call matter in the traditional sort of material scientific way of looking at it? Is that where you see it expressed?
Well, see, in the 19th century, scientists thought that matter was just hard, impenetrable stuff, billiard balls and things, billiard ball atoms. But through quantum physics, as the philosopher of science Karl Popper said, through modern physics, materialism has transcended itself, because the fundamental principle is no longer matter, but matter itself is made of fields and energy. And so an atom, for example, is vibratory patterns of activity within quantum fields. So matter is actually both. It's the energy, but energy is promiscuous and has no form by itself. It can take any form, like the energy in your electric plug socket. You can operate an electric toaster, a hairdryer, a computer, a fan. Energy can do all those different things. It's not confined to one form. So energy can take any form. So that's why we need, and we do have in physics, two basic principles for matter: energy and form, or energy and fields. So, if we go to the book of Genesis again, it's right there in Genesis verses, the first three verses of book 1 of Genesis. Verse 2, and the Spirit of God moved on the face of the waters, or the deep. Well, that's basically, the Spirit is the same word as wind and breath. It means the same thing. And if you have wind moving on the face of the deep, the water, it creates waves. So you have the first stage is movement, creating waves. And the verse 3, and God said, let there be light. And light and darkness appear, and they're separated. The creative word or logos is in verse 3. So you've got actually this Trinitarian principle right there in the first 3 verses of the book of Genesis. I think that seeing that energy and form, or energy and fields, are the fundamental reality, which is what modern physics actually tells us. This is not some abstruse deduction. It's simply literally what's in physics textbooks. That's what an electron is. That's what an atom is. Very different view from 19th century materialism.
And isn't what we're doing with science, and I'm saying this just to kind of prod and look at the assumptions, the metaphysical assumptions of science, because science likes to pretend that it's playing the purely objective game. We have no assumptions. This is just what it is. But it seems to be, and you mentioned this in Science Set Free, you mentioned in passing, is a very, very interesting point, is that we might be, in a sense, stuck in metaphor. So what we seem to be doing in science is we take the highest technology that we've been able to create to date, and we say this is what the world is. So in the 17th and 18th century, it was clocks and machines. In the 20th century, it's a computer. Now the world is a computer. Today, it's more like disembodied data and information. We have a hard time conceiving of the universe as anything more than the most complicated thing we happen to have been able to create at this particular time. Is that fair to say?
Yes, I think we have an incredibly anthropocentric view of the world in mechanistic science, actually. It pretends to be supremely objective and have moved beyond old-style thinking in every way. But in fact, it's the exact opposite. The very idea of laws of nature, for a start, is anthropocentric, because laws only occur in human societies. And as C.S. Lewis pointed out, they only occur in civilized societies. Tribes have customs. And to say that a stone falls to earth because it's obeying a law, as Lewis said, makes it a man and even a citizen. So that's incredibly anthropocentric. And the idea of laws of nature was plugged into science at the beginning of the 17th century by Sir Francis Bacon, who was one of the prophets of modern science. And Sir Francis Bacon's day job was Lord Chancellor of England. He was in charge of the entire legal system of England. So he was a lawyer, so he projected laws onto nature. And then mechanistic science took machines as the primary metaphor for the whole of nature. And machines don't exist in nature. They only exist when humans make them. So this was taking a man-made construct as the metaphor for the whole of nature. And so it's incredibly anthropocentric instead of being the opposite, as many mechanistic materialists would like to think. The traditional metaphors for nature, which were used by the ancient Greeks and used all over the world in every culture, organic metaphors, the universe is an organism. Plants and animals are living organisms. They're not machines. They actually are exactly what they are, namely living organisms. Even the patron saint of the atheistic humanists, David Hume, the 18th century philosopher, in his dialogues on natural religion, says he sees no reason why we should prefer the idea that the universe is a machine to the idea that it's an organism. There's nothing in nature that tells us it's a machine, not an organism. And Hume actually argues that the organism is a preferable concept. So even Hume, who is cited by all the atheists and the materialists as being one of their great prophets, was very clear on this. It's nothing but a metaphor, and it's not necessarily the best metaphor.
And in Science Set Free, one of the assumptions that you look at is this notion, because when we reduce the world to a machine, you said machines are purposeless, and so therefore we are purposeless, or the world is purposeless. And I'm very curious to how you sort of explain if we do see life as biological organisms, which is, what we are. As you said, we're not machines. We can make machines through the laws of nature, but is it really fair, or is it really productive to look at ourselves as machines? What is the purpose of biological creatures? And we could really look it down to the most fundamental aspect. If you take a plant, if you take really simple biological organisms, what is the purpose? We could look at it factually and say, what happens at the end of the life? Well, at the end of the life of a biological organism, all of the stuff that it is gets put back in the earth, in a sense, right? There's a contribution back to the world. And so its raw materials and everything that it was end up sort of going back in the pool. It's not, in a sense, the end, and it's completely meaningless. And so as we kind of take the metaphor of the machine and we replace it with the metaphor of the biological creature, I'm curious to get your thoughts. What does that do to the idea of purpose?
There's 2 points here. First, machines, of course, do have purposes, but not purposes of their own. The reason we make them is because they have purposes. People make and buy motor cars so they can drive from one place to another, and they have computers so they can compute things. But it's not intrinsic to the car. This was brought home to me once when I was in Ireland, and we were in Western Ireland, and there was this thing for visitors. You could ride on a horse around some particular beautiful part of Ireland. So we hired these horses and stuff. I found this, haven't had much experience with horses, and this horse definitely had a mind of its own, and it seemed to know exactly where it was going. And I thought, oh, well, it's been well trained and stuff. So I just let it go where it was going, and it arrived at a stable. It had just gone home. So it had a purpose of its own, which was not my purpose. However, if I'd got in a car, then it would have gone exactly where I wanted to, because it had no desire or purpose of its own. I suppose the most fundamental purpose in living organisms is survival and reproduction. Even the most simple and basic living organisms, the very first cells on Earth that gave rise to life as we know it, must have had these purposes already, because if they hadn't, they wouldn't have survived and reproduced. So there's a sense in which these purposes are built in to all living organisms right from the beginning. And so survival and reproduction are very, very strong purposes that have enormous power. And, we see it in human life as well. We have basic biological instincts which are deeply embedded in our nature. Like the sexual drive, for example. This isn't just something you rationally turn on and off. I mean, it's something that's enormously powerful, especially when one's younger. This is obviously something we share with other animals, and if we didn't have it, then no doubt we wouldn't reproduce. So this is very deeply embedded in our nature, and the desire to survive is deeply embedded in our nature, as it is in other organisms. And it doesn't necessarily mean individual survival, because within our bodies, a lot of cells die as we develop, and all the time. Blood cells, skin cells, intestinal lining cells, appearing from stem cells. They have a limited lifespan and then they die for the good of the whole. In plants, as they grow, all the cells that turn into wood cells, they thicken their walls and they turn into little tubes to conduct water up the trunk of the tree. And they commit suicide, so they're dead, empty cells. And then in termite colonies, the worker termite and ant colonies, the workers do all the work they have to do, and they don't reproduce themselves, but they're part of the whole colony reproducing. So they die, but they have a fairly short lifespan. I think we can see that these fundamental purposes are built into life. Now, this is true of individual organisms or societies of organisms. It doesn't necessarily tell us what the purpose of the whole evolutionary process is, but it does tell us that, just from observation, that the purpose of individual organisms or societies is survival and reproduction. That's the most basic purpose.
Is there more than just survival and reproduction, in the sense that, is there also this idea, just like you gave the example of the colonies, or if you chart the sort of evolution of mankind, is there also the notion of somehow or another improving life for the species as a whole? Is that also perhaps part of the purpose of biological organisms, or not? Or is it just really survival and reproduction, the selfish gene? Is it really just that? And in the sense that we go back to a kind of a Darwinian, and I know that Darwin had a crisis of faith, and is life just survival of the fittest? Or when we kind of look at the broad evolution of mankind, and you look at progress in all sorts of different areas, the reduction of suffering, the continuation of life, the more empathy spreading, is that also perhaps part of the purpose?
Well, I mean, there are some species which haven't changed for a very long time. I mean, horsetails or equisetum, have been around for, 200 million years or something, more or less unchanged, the so-called living fossils. So not all species are engaged in a kind of onwards and upwards progressive movement.
But humans specifically.
Yes, well, when we come to humans, then it's a very different story, I think, because there are two elements here. First, humans are social animals, and all social animals have cooperative arrangements within the society. There's a kind of altruism in all social species. Otherwise, they wouldn't be social species. Birds lay eggs in their nest, and the parents feed and raise their young, and they're prepared to die to defend their young. And this is true of many mammal and bird species. Helping other members of the group, which we find the most extreme form in insects among termites and ants, and wasps and bees, as I mentioned. But even in species that aren't particularly social, like cats in the wild, they're much less social than dogs in the wild and wolves. But even there's a degree of cooperation for raising the young and feeding the young. In human society, because we're a social species, there's mutual help and cooperation, which is just built into our society as a social species. But we then have, with the development of cultural inheritance and language and cultural inheritance, we have a kind of cumulative cultural evolution, which is the main thing that makes humans different from other species, that we have this conceptual, linguistic and cultural evolution, which has been, slowly at first in the Stone Age, where you'd have cultures going on for hundreds of thousands of years with the same kind of stone axe. And then you have sort of breakthroughs, and something around 50,000 years ago, the beginning of art and that kind of thing. And then 5,000 years ago, the beginning of civilization and agriculture, and 10,000 years ago, and then a kind of cumulative build-up. But most human societies, most of the time, were based on the principle of doing things the way they've been done before. I mean, Australian Aborigines, for thousands of years, had a culture that repeated what had gone before, more or less. And most human societies did that. It's only relatively recently that we've had the cult of the new, where innovation has been seen as a good thing, and where the more innovation, the faster and faster, the better. So we've now reached the point where our whole society is based on dizzying pace of change. As everything gets faster and faster and faster, rate of change of technology and change of society and that kind of thing, and media and increasing population, all those kinds of things, which in the 19th and 20th century was seen as progress, untrammeled, unalloyed progress. Now we tend to see it in a rather different way. Things have got horribly out of balance, and we're out of balance with our environment. We're out of balance with the whole planet and with each other. The naive faith in progress, which was almost universal when I was at school, is quite rare to find nowadays. I mean, you still find it in a few techno-optimists, but who are very influential, the sort of Elon Musks of this world. Most people have a more moderated view of progress and development, and not all change is necessarily for the good.
It seems that we've focused in on one form of progress. So, I mean, again, with the materialist idea, we have a notion of progress that is really focused on material progress and technological progress. Does that take our attention away from other forms of progress, moral progress, ethical progress, spiritual progress? Do you think that that is something that we're going through?
It would be hard to argue that we're undergoing a massive period of spiritual progress at the moment, I think. I mean, if you look at Europe in the Middle Ages, for example, you had a society where the principal aim of the society was to reflect the glory of God. And most of the surplus production of the society that didn't go into building castles for kings and lords went into building cathedrals. And here in England, we have these amazing cathedrals. Even today, they're utterly amazing buildings, Lincoln, Winchester, etc., in France, Chartres, and so on. Buildings that are staggeringly impressive, built with a very limited technology, just ropes and pulleys and bullock carts and things. And when the population of England, which is now about over 60 million, was only 3 or 4 million, they were able to produce these astonishing structures because the society was aimed towards reflecting the glory of God. And there were all these monasteries and hermits and holy people and nuns and many of them doing work to help the poor, running hospitals, running schools, running universities, and so on. Now we have a society dominated by billionaires who build huge buildings for banks and industrial complexes and stuff. The main aim of most people seems to be to make money. So I wouldn't necessarily call that moral progress. I think one area where one could say the kind of Judeo-Christian idea of moral progress has mutated into a secular form in our society is that in the Judeo-Christian tradition there's a very strong emphasis on caring for widows and orphans, for social justice, and God is always seen as a source of justice, and it's a very important thing. So I think the woke movement and some of these more extreme forms of sort of inclusiveness are actually a secularization of this Judeo-Christian principle. And that is a kind of moral progress, you would say, that we're no longer discriminate against people on the basis of their sexual preferences and so on, unless they're pedophiles. So there are still some limits, but there's been a move towards ever greater inclusiveness. You could see that as a kind of moral progress, but it goes hand in hand with the very same societies building ever more powerful weapons of mass destruction, which can indiscriminately kill, millions of people, civilians and civilian populations, whereas the old rules of war were that warriors killed other warriors and left women and children alone, and left hospitals and schools alone, and so on. Well, no, it's just indiscriminate destruction all too often. I would say that there's the ideal of moral progress, which is built into our religions. And I think that is the most wonderful thing, and is probably the highest aspect of humanity, at least I think so. But if you look at modern Western societies, it's hard to see that that's the most dominant ethos that's propelling the economy, the educational system, the commercial and industrial system.
Very interesting. Since Science Set Free, it feels like your work took a direction, almost a kind of spiritual empiricism, which is not as focused on, the sort of bigger theoretical issues, but really studying spirituality from the perspective of the measurable effect of different spiritual practices that human beings have developed over really millennia. In your Ways to Go Beyond and Science and Spiritual Practices books, the evidence is pretty overwhelming that these practices work. I mean, even material scientists like Sam Harris and others, he's got an app that focuses on meditation. I think a lot of even more traditional material scientists will accept that these spiritual practices work. Some of them, of course, will simply call placebo to explain the effects. From your perspective, why do these multiple, you really go over a lot of them, a lot of these different spiritual practices, why do they work from your perspective?
I think the point of of spiritual practices is to connect us with forms of consciousness greater than ourselves. They're all about connection with something bigger than ourselves. Just to name a few, gratitude, for example, a very fundamental practice in all religions, is recognizing how much we receive from other people, from nature, from the universe, from our ancestors. We didn't make ourselves. We're born into a world and we inherit a culture and buildings and an educational system, scientific and cultural system. We're cared for as babies. We're looked after by a medical system. All of this, if we can, insofar as we receive so much, if we give thanks for it, it's a kind of flow that connects us. We connect ourselves with the flow of which we're part. If we don't give thanks, if we just take it for granted or feel we're entitled to it and then complain we haven't got enough, then we block the flow. So that's a flow principle. Meditation and prayer are both about connecting with forms of consciousness greater than our normal state of consciousness. Now, materialists like Sam Harris might say that meditation is just changing the brain so that we feel better in some way. It's all inside the head. Although I gather he recently has gone over to idealism as his main philosophy rather than materialism. Idealism is surprisingly making lots of converts at the moment. A lot of materialists are jumping ship. The point about these spiritual practices, they make the experience of connection with something greater than ourselves real for us because we experience it, we know it directly. As I see it, religious doctrines enable us to interpret and make sense of this fundamental connection that we can experience directly. But I think all religions start from direct experience. They don't start from doctrines. Moses didn't experience God in the burning bush and on Mount Sinai, just through studying books in a library or something. This was a direct, powerful experience. His face shone. People were afraid to look at him. He was so transformed by this. And Jesus, at the moment of his baptism, when he came up from the River Jordan and had this experience of his direct connection with God, the divine presence and with him. Again, that wasn't through studying in a rabbinical seminary or something. And the Buddha didn't become enlightened through doing a PhD. These were all direct experiences on which religions are founded. They've been cultivated by people, monks and nuns in monasteries with Hindus, sadhus in caves meditating in the Himalayas, Kabbalistic mystics, in Judaism. There's been these traditions, religious traditions, have always had a strand within them of direct spiritual experience, which is what it's primarily about. And all religions contain within them spiritual practices that give people that sense of connection. Singing and chanting together, for example, gives a sense of connection with other people, but also by morphic resonance with all those who've sung and chanted the same thing before. So there's a kind of connection across time. Rituals, ceremonies, festivals, all of these involve a connection with others in the present, with the ancestors in the past, and with forms of consciousness greater than the human level. So the reason I was keen on these books is because, why I wrote these books, is because when you actually use the scientific method to look at spiritual practices, it turns out that they're, generally speaking, beneficial and have measurable effects on physiology and well-being. It's a so much more constructive way of bringing together science and spirituality than armchair arguments where, atheists just say, show me the evidence for God. He's not out there. They haven't found him with spaceships and stuff. And those kind of futile arguments don't get us anywhere. Directly experiencing the spiritual realm and this interconnection is a way into, just a knowledge of the fact we're part of something greater than ourselves, a direct experience of it, not something you've read in a book or been told you ought to believe.
Yeah, and I'm happy that you mentioned morphic resonance, because I wonder if that's also a feature of morphic resonance. The idea has been pretty controversial. As I understand it, your hypothesis is that individuals within a species are connected somehow through a field of consciousness to other individuals within that species, and even perhaps across time, so across space and across time. So I wonder if this is also a pattern that you see in morphic resonance, and how confident are you today, after hypothesizing and studying this phenomenon for many, many years, how confident are you in your original assumptions and hypotheses that something like a morphic field does exist within a species? And please don't hesitate to correct me if I missed something on the theory. I know it's a lot more detailed and a lot more sophisticated than what I just laid it out, but some people may not be aware of what the theory of morphic fields is.
Perfectly good summary. But to expand the summary, it's not just about living species, it's not just about biology. I suggest the so-called laws of nature are more like habits, and this applies to crystals, molecules, and so on as well. If you make a new kind of crystal, there won't be a morphic field for the crystal to start with. It won't have a previous form. It hasn't existed before. But if you go on making these crystals, they'll get easier and easier to make. If rats learn a new trick in say Montreal, then rats in London and New York and Melbourne, Australia and New Delhi will learn the same trick quicker, just because the rats here have learned it. If millions of people do a 5-letter Wordle puzzle published every day by the New York Times, the people doing it in the morning, when very few people have done it, might take longer to solve it than those who do it in the evening. And there's a research project going on here in Britain at the moment, which suggests that is actually happening. So there's a kind of influence across time and space based on similarity, and that's what morphic resonance is. Well, when I first proposed this in 1981 in my book, A New Science of Life, republished in North America under the title Morphic Resonance, is the third edition of A New Science of Life. When I first proposed it, predictions I made were that in biological inheritance, genes are grossly overrated. And I said that genes would only account for a small proportion of inheritance, because all they do is code for the sequence of amino acids in proteins. They don't explain the shape of your face, or the instincts of a spider in making webs, or the migratory ability of cuckoos, and so on. None of those are in the genes. So you need the genes to make the right proteins. So when I said in the 1980s genes are grossly overrated, I didn't get much traction, because everyone was totally into genes. The selfish gene was the dominant theory. In the late 80s, the Human Genome Project was launched with the high hopes that we'd understand human nature at the molecular level through the Human Genome Project. It was completed in the year 2000, and it was a tremendous disappointment for people who'd invested many billions of dollars in it. First of all, they thought there'd be at least 100,000 genes. It turned out there's only about 20,000 in humans, about half the number in a rice plant. and, a bit less than a sea urchin. So it wasn't at all what they'd expected.
Pretty humbling realizations.
Exactly, and it got worse, because then when they started, these commercial companies like 23andMe offered to sequence genomes for people so they could predict their likelihood of getting breast cancer and other diseases and so on, because they thought all of this would be predictable from the genes. It turned out the proportion of these things you could predict from the genes is actually very small. Schizophrenia can be predicted from the genes with about 2.5% accuracy, breast cancer less than 10%, and even height, something as simple as height, it's less than 20%. At first it was 10%, and they've scraped the bottom of the barrel and done all sorts of new assumptions, and they've managed to get it up to nearly 20%. But we know that height is heritable. It's inherited from parents. Tall parents tend to have tall children. We know that these things are inherited, but the genes account for only a small part of it. And the part they don't account for is now called, in biology, the missing heritability problem. And the missing heritability problem, which for most characteristics is about 80% or more of the heritability, is not accounted for by genes. Now, some may be accounted for by epigenetic inheritance, which is the inheritance of acquired characters, which in the 20th century was the ultimate taboo in biology. It's now been rebranded epigenetic inheritance and is one of the hot topics in biological research. And the assumption is that this can be explained by some molecular mechanisms, as yet not fully understood. But actually, a lot of it looks like morphic resonance to me. So what's happened in terms of biological inheritance since the 1980s has made me not feel less confident about morphic resonance, but more. I don't claim that morphic resonance is proved, because there's been very little actual research on it. It's still incredibly controversial within the sciences, and very few people within institutional science have ever done any work on it because they're afraid of losing their job, endangering their career, and so on. I mean, there's tremendous intolerance within the sciences for unorthodox ideas, which inhibits scientific discovery and inquiry. In that area, then, developmental biology, I think morphic resonance is more plausible than ever. Within cosmology, the idea that the regularities of nature evolve in an evolving universe, the Big Bang theory says the whole universe evolves. A number of cosmologists, including Lee Smolin, who's based in Canada, have now started talking about the evolution of the habits of nature. Smolin talks about the principle of precedence. Once things have happened, they're more likely to happen again, which is another way of talking about morphic resonance, in my view. In many areas, there's been research has moved in the direction of the kinds of things that morphic resonance has predicted all along. So it's still not taught in most universities. It's still regarded as a heresy. It's still, lots of people are interested in it, but people who are interested in it, who work in academic institutions, often keep quiet about their interest in it because it's a dangerous view. I don't believe in it as a kind of belief system, or I just think it's the most plausible way of interpreting what's going on in the natural world and in the evolutionary process. And the evidence makes it more plausible, not less plausible. But it's still not something where you could say this is definitely proven, or there's overwhelming evidence. There isn't. Most of the evidence is circumstantial.
It's very, very interesting. And there's this element of openness in your work that I feel is mostly lost in modern secular scientific culture. We sometimes seem very close to exploration. And to close up, I mean, I could keep talking about this stuff for hours with you, but I'm just curious, are we seeing the beginning of more openness in science? You mentioned in a little clarification to your TED Talk that, in the US, for example, there's a budget now for a little bit more open-minded research in science that detracts from the more conventional views. If the origin story of the universe was not just random and empty, I'm curious, is the destination a little bit more optimistic? Do you see more openness? Do you see more, in Science Set Free, you mentioned one of the issues with modern science is that there's no more mystery, right? We know everything there is to know about the universe, and the only thing left to learn from here on out are just the details. Do you think that something more fundamental, a more fundamental exploration of the nature of the cosmos is possible within science, and perhaps from something outside of science that could inform science more and more?
Oh, definitely. I mean, that's why my book, Science Set Free, is called Science Set Free, because I think that when we break out of these constricting 19th century materialist assumptions which dominate the sciences, all sorts of new possibilities open up. And there are many people in policy think tanks who are worried that there's no real breakthroughs happening in science at the moment. And probably one of the few recent breakthroughs is artificial intelligence. But most other things, we're living on the capital of the past. I mean, radio, television, the transistors, all these things are from the 20th century. And radio was sort of late 19th century. What in think tanks is called the innovation deficit in science worries a lot of policymakers, because more money is spent on science than ever before. And there's more scientific papers published than ever before. There's more scientists employed than ever before, more scientific journals than ever before. But what does it amount to? A lot of it doesn't amount to very much. And because the existing system is basically set up to give incremental improvement along established lines, does a good job at incremental improvements along established lines. But things that would be disruptive or transformative or revolutionary are suppressed by the present scientific system, because scientists are rewarded in their careers by the number of papers they publish in peer-reviewed journals. That's how they get ahead. If you want to be a top scientist, that's the route to success. And it's a perverse incentive. It doesn't mean you have to change the world for the better. It doesn't even matter your papers are true. If you get them published, in a lot of bogus results are published, a lot of science, most papers turn out not to be reproducible. That's a big shock to many people in science. So what matters is getting them published in peer-reviewed, high-prestige journals. So if you work in a new field of science, you won't get it into a top journal like the Journal of Molecular Biology or something, because if it's not molecular biology, if it's something quite different, you won't get it in these journals, and you won't get lots of citations, and you won't get career advancement and more grants and things. So the present system militates against real innovation, and so does the dogmas that constrict it. Now, that's all to do with the institutional framework and organization of science. Within the sciences, there are lots of scientists who are much more open-minded, who have moved on beyond the materialist paradigm, who would like to see things work differently. But usually this is in private. I have plenty of friends who really eminent scientists, well-known people who are friendly. I talk to them, they're open-minded, we discuss these things. But when they get into public, you would never guess, because, I'm dangerous to know. And so in public, they appear to be conventional. I think the present state of play is a bit like the Soviet Union under Brezhnev, where to get ahead, you had to pretend you believed in Marxist dialectical materialism. And, in party congresses, everyone had clapped dutifully at the right time and so on. But how many really believed it? When the Soviet Empire collapsed, how many true believing communists were there? There were certainly some, but not that many. And I don't think there's that many true believing, fully signed up, committed materialist, atheist types within science. In recent surveys in Britain, France, and Germany have shown that about 25% of practicing scientists, medical people and engineers and mathematicians would identify with the materialist worldview. 75% don't.
You would think it's more. You would think it's more because publicly, that's still the paradigm. That's still the opinion you have to have.
Yes, that's what you have to have in public, and you'd think so. And very loud, people like Richard Dawkins speak through a kind of megaphone and claim to be speaking for the scientific community. It's actually a minority position now. But the media don't know that. The educational system doesn't know that. And schools and universities are still teaching unreconstructed mechanistic materialism as the scientific truth. Most scientists, if they've gone through that system, have to wait either until they have a midlife crisis or until they take psychedelics to undergo a kind of paradigm change. And many, of course, have taken psychedelics. And this actually is one of the areas of science where there is a kind of opening in consciousness studies. Psychedelic research is now mainstream. It's still not funded by official funding agencies, but there's enough billionaires who've taken psychedelics and got interested in it who are prepared to fund it philanthropically for this field to, rather surprisingly, to have taken off. Also, other areas of consciousness studies, like the study of near-death experiences, end-of-life experiences, lucid dreams, mystical experiences, these are areas, I think, where science has broken already out of the materialist paradigm, but they're still very small areas compared with mainstream materialist psychology and behavioristic thinking and cognitive behavioral therapy and that sort of thing. So you can see growing shoots within the scientific world, but they could be so much bigger, and there could be so much more transformative and truly innovative work going on in science if these dogmas and institutional structures didn't hold it back.
Amazing. And this is perhaps closing a loop on another connection point between science and spirituality, and it's perhaps renewing with this spirit of openness and curiosity and amazement and opening up to the mystery of the universe, which is really very compatible with the first stage of scientific thinking, which is being radically open at the level of hypotheses, and then designing experiments, and then eventually, of course, not wanting to abide to false theories, but being open. If you restrict the first stage, if we say, well, at the hypothesis level, instead of being open, we now have this fixed belief, it seems to me that you have downstream consequences where you could kind of start having what you describe as diminishing returns of the entire enterprise. And maybe this is an opportunity for not to water down the scientific method or scientific standards at all. In fact, we can do it at the highest, most stringent level, but still retain our openness at the level of hypothesis.
Absolutely. I couldn't agree more. And I think that, when that happens, or it's beginning to happen on a small scale, science will become much more sort of user-friendly and much more in accord with spiritual traditions and the sense that we live in a mysterious universe. We certainly understand a lot more than we used to, but there's so much we don't understand. I think the besetting sin of modern science is arrogance. It's a kind of pride that, we've figured it all out. All these traditional religions, indigenous worldviews and stuff are nothing but superstition of primitive, childish people and stuff. Whereas as we study more what indigenous people have learned about nature and their connection with animals and plants and the earth and stuff, we have a lot to learn from other cultures. And they certainly lived in better harmony with nature than modern industrial society. When we're less arrogant, I think science would be better and more life-affirming.
That sounds great and like a great project, and I hope your message resonates very broadly and widely. Dr. Sheldrake, it was a true honor, a true pleasure to talk to you after years and years of learning from you, and I hope many, many years to come. And I really hope we'll get another opportunity to connect. Perhaps next time you're in Canada, we'll see. But hopefully we get a chance and an opportunity to continue this conversation in the future.
A real pleasure talking with you, Fred. Thank you.
Thank you so much.